Okay, next we have osteochondrosis. Unfortunately, this presentation doesn't have a lot of pictures, so I'll try and make it interesting. These are other developmental orthopedic diseases, so fasciitis, visual dysplasia, subchondral bone cysts, cervical and vertebral malformations, and angular and flexural limb deformations. And we did mention the last one in the previous presentation. So what's osteochondrosis? Basically, it's the process of endochondral ossification. What does that mean? Well, whenever you see the word chond, it kind of means cartilage. So what happens is when this ossifies, this is when cartilage becomes bone. Now, if osteochondrosis takes place, it means that this has been disturbed. So it results in softening, thickening of the growing articular cartilage. So this is the cartilage in articular joints, and it can lead to semi-loose or completely loose joints, which is osteochondritis dissecans. So if you see this, you know what it means now. So cartilaginous fragments are known as mures articularum. These are also known as chip fractures, which are mineralized in horses. Now, what's endochondral ossification? I don't know if this picture is going to help, but I'll try and use the picture. So when we talk about the primordial skeleton, this is the fetal skeleton. It's laid down basically as a cartilage structure, so the whole skeleton is made of cartilage, and it's very well vascularized until, unlike mature cartilage. That's why when you get your ears pierced, they say, you know, the cartilage won't heal well. So ossification is when you have long bones and the diaphysis, so this is like the middle of the long bone. It has primary centers for ossification, as you can see, and at the time of birth, all diaphyses become bony. So the middle part of the long bones start out as cartilaginous, then when the baby's born, it becomes bony. But there are many secondary centers of ossification in the epiphyses, so the ends of long bones, such as, let's say, the secondary centers could exist in, say, apophyses as example, or cuboidal bones, and they're still partly cartilaginous at this time of birth. Now, in terms of the longitudinal growth of bone, so let's say up and down, it occurs at the growth plates known as physes. I'll just show you the word. And at the articular side of the epiphysis, you'll see cartilage transformation into bone, which is known as endochondral ossification. You may see the letters EO throughout this. Sorry, there aren't a lot of pictures, I'll try. Okay, so in these structures, chondrocytes come from the germinal layer of resting cells. So, okay, we said the physes is usually at the end of a long bone, but it's usually in cartilage form. So these cartilage have chondrocytes, which are cartilage cells, coming from the germinal layer of resting cells. These undergo mitosis, proliferation, they hypertrophy, and also undergo cell death. They're covered by an extracellular matrix, which basically, along with the chondrocytes, forms the primary structure of the primary bone. Forms the structure of the primary bone by osteoblasts. So all this cartilage becomes bone using osteoblast cells that originate from the metaphysis. The primary spongiosa, so the spongy bone, is formed while undergoing something called continuous remodeling by the force of mechanical loading. So basically, the reason cartilage becomes bone is because of weight. And it's according to Wolff's law during the entire growth period of the foal. This entire process of cartilage remodeling is then followed by calcification of cartilage. So the cartilage is kind of changing in shape. It then becomes calcified into bone. You get deposition of primary bone and successive remodeling into bony trabeculae, and it occurs in young growing animals. This process is known as endochondral ossification. Honestly, I don't think this slide was necessary. So pathophysiology. So I think this is when things go wrong, let's say. So when cartilage cells die in delayed osteochondritis, OC? I'm not sure what OC is. Let me check. Okay, I think it's osteochondritis dissecans. Let me just, yes, osteochondrosis. Sorry. Okay, so when we have osteochondrosis, the death of the cartilage cells is slow. While the cartilage vascular canal, so the blood vessels regress as the animal gets older. Because as I said, remember, when an animal is young, cartilage is vascularized. Later in life, cartilage isn't. And this is up to 7 months of age. This affects the nutrition of the deeper layers of the retained cartilage that can't be sufficiently nourished, and this leads to necrosis. So you get an area of weakness with irregularities, like thickness of the epiphyseal cartilage, for example. So for example, it's saying biomechanical influences, especially shearing forces, lead to the formation of fissures, so like holes in the cartilage, and you get cartilage flaps or detachment of the cartilage or fragments and subchondral bone. And basically these forces, if they're mainly compressive, you get the cartilage folding in these weakened areas and you can get subchondral bone cysts. So, okay, this all sounds odd. How does it occur? So it's both congenital and acquired, so genetic. So if you, heritability is highest for the tarsocrural joint. And yeah, it's a multifactorial disease. So it also is forever changing, like sometimes it gets better, sometimes it gets worse. If we talk about acquired reasons, there's joints, nutritional reasons, so it's higher energy intake or imbalances of minerals and elements. Some of these are obvious, but I'm going to go through some of them. So higher energy intake, what this leads to is hyperinsulinemia, so too much insulin. And basically insulin also has derivatives like IGF-1, 2, and it has a direct effect on endochondral ossification. And what happens is they're meant to stimulate chondrocyte survival or suppress apoptosis of these chondrocytes. But insulin also stimulates removal of the thyroid hormones T3 and T4 from the circulation, and these are also involved in the chondrocyte differentiation, because basically they enter blood vessels to allow the cartilage, which is well vascularized, to be converted into bone. And you have imbalances of elements like low copper, high zinc and cadmium, high phosphorus and low calcium. So just remember, anything that's low is usually C, except cadmium, but everything else is high. And I'll just end here and we'll start the next video.